All right, here we have midterm review, section D, concepts. So there's just a few questions here, just simple concept questions. What quality do, wow, typo. What quality do scalar variables have? Scalar variables, so examples of scalar variables. Examples that include distance, speed, time, mass, etc. Okay? They all have magnitude. Magnitude is the fancy science word for size. All right? How far, how fast, how long, how big, okay? Those are all giving you a number. They have magnitude, they have size. Then the next question asks, what qualities do vector variables have? So qualities is now a pluralized question, and we're talking about vectors. Vector examples, all right? They include displacement, velocity, acceleration, and force. Okay, so there's some examples. What do they have? Well, they have magnitude, they have size. All right, each one of those would be represented by a number, which is going to be your magnitude. But what is unique about these compared to the scalars is that these also have direction. Displacement has direction, distance does not. Velocity has direction, speed does not. Acceleration has direction, force has direction, okay? Time does not have direction, mass does not have direction. So magnitude and direction make make vector measurements what they are. Okay, what does it mean for an object to have a positive velocity? It means it's moving in the positive direction. Okay, what does it mean for an object to have a negative velocity? It just tells us what direction it's moving in the negative direction. So this goes back to the idea that of vectors. Okay, velocity is a vector measurement. It has both a magnitude and a direction. So velocity is both a combination of speed and the direction it's moving. So when we're talking about a positive velocity, the fact that it's positive tells us the direction that it's moving. The direction is told in the positive and the negative determines the direction when we're talking about velocity. All right. Next, if an object has a negative acceleration, it can mean two things about the object's motion. Describe both motions using examples. Okay. So, negative acceleration. That's the topic. All right. Decelerating, which means you're slowing down, aka the velocity, not the velocity, let me clarify. The speed is decreasing. That would be a negative acceleration. Okay, so that's one example. The other example is moving in a negative direction. I should clarify. Be more specific with that. Accelerating, which traditionally would be positive because the velocity is increasing, accelerating, but in a negative direction. Okay, so the negative direction is where we could have a negative acceleration. All right, Over here, slowing down or decreasing speed is also an example where we have a negative acceleration. Okay, so a simple example of this would be falling objects. Okay, because gravity, your 9.8 meters per second squared, is accelerating it downwards, so it's a negative. All right, last question in the section D concepts. When recording scientific data, why is it important to include the units of measure with each number? All right, so let's say I write down a whole bunch of numbers. I've got, all right, the 5.4 car is going 3.2 for 7.9 at a 6.3. Okay? Without any units of measure, we have no idea what those numbers mean. All right? A 5.4 car, 5.4 what? Okay? Going 3.2, 3.2 what? Okay, going, so that probably has something to do with motion, but that could be velocity or it could be acceleration. Okay? So this right here shows us why units are so important. Units of measure tell us what the number is measuring. Tells us what the number is measuring. What does that number mean? Okay, so that are the concepts on section D.